Welcome to AI Frontiers, unpacking 74 machine learning papers from a single day. Today's episode, Machine Learning's Next Leap, cs.LG, August 6, 2025, explores the newest breakthroughs in machine learning research. We'll discuss efficiency, robustness, interpretability, privacy, innovative architectures, and more, featuring the standout paper Agnostics by Borik-Grusicki et al. Join us as we journey through the field's current challenges, solutions, and the future of AI. Imagine this: artificial intelligence capable of writing code in any programming language without needing explicit rules for each one. Now, large AI models that once required rooms of servers can run seamlessly on laptops and even mobile devices. AI is not just matching our needs, but sometimes even predicting them. As researchers pursue models that are smarter, leaner, and more reliable, 74 new papers from a single day offer both answers and surprises. The era of universal anticipatory AI is no longer science fiction. It is research reality. Why do today's machine learning papers matter? At its core, machine learning is about teaching computers to learn from examples, much like a child learns to ride a bike through practice rather than detailed instructions. The cs.LG category is a laboratory where new machine learning designs and ideas are tested. Innovations in this space drive the technology behind voice assistants, autonomous vehicles, medical diagnostics, and more. Our goal in this episode is to decode what's new in the field, explain why these developments are significant, and connect the latest research to real-world impact. Machine learning is often described as the Swiss Army knife of computing, versatile, adaptive, and continuously evolving. Today's 74 papers represent 74 new tools, each designed for a specific, diverse task. Machine learning laboratories function like testing grounds for new bike designs, focusing on both speed and stability. The influence of these innovations extends across areas such as speech recognition, computer vision, public policy, and scientific discovery. For example, advances in this field power everything from self-driving cars to climate forecasting systems. A central theme in current research is efficiency and scalability, packing more power into smaller models. The aim is to shrink AI models without sacrificing their cognitive abilities. One notable example is FlexQ by Zhang et al., which compresses large language models to 6-bit precision per parameter, making them lighter on memory while preserving performance. This process is akin to rolling clothes to maximize suitcase space, enabling AI deployment on smartphones, edge devices, and low-power hardware. The underlying technical concept here is quantization, which reduces numerical precision to achieve model compression. Another critical theme is robustness and reliability, ensuring AI systems do not fail when it matters most. Robustness involves making models resistant to errors and trustworthy in real-world scenarios. For instance, Wang et al. Demonstrate that certain transfer learning approaches can reduce the reproducibility of results, highlighting a trade-off between adaptation and stability. This is similar to tuning a car for speed, but increasing its risk of breakdown in inclement weather. Robust and reliable models are essential in healthcare, autonomous driving, and safety-critical applications. The technical concept of transfer learning, adapting models to new tasks using prior knowledge, remains an area of active investigation. A growing focus in machine learning is interpretability and the integration of domain knowledge. Researchers aim to make AI decisions transparent and understandable. An illustrative example is Li et al., who embed physics principles into machine learning models for welding applications, enabling more reliable predictions. This is akin to working with a chef who finally shares the recipe behind a dish. Tools that explain AI step by step are gaining prominence. Yet systematic reviews indicate significant gaps remain, particularly for multimodal data that combines text, images, and sound. Let's highlight 5 mini-stories of progress from this collection of research. First, Boruch-Grishecki et al. Introduce universal code generation, enabling AI to learn any programming language. Kim et al. Provide new mathematical guarantees for quantization, ensuring compressed models maintain reliability. Chen et al. Use causal machine learning to uncover hidden effects in energy policy, revealing impacts beyond simple averages. Smith et al. Apply retrieval-augmented forecasting to improve water level predictions in the Florida Everglades, combining historical data with foundation models. Finally, Patel et al. Propose a multi-rater Turing test for medical AI, using expert human judgment to assess the trustworthiness of model predictions. The featured paper of the day is Agnostics by Boruch-Grishecki et al., which addresses the long-standing problem that code-generating AI models have been limited to popular programming languages. Historically, each new language required custom engineering and significant data collection. Agnostics disrupts this paradigm by decoupling code generation from language-specific features. The approach involves rewriting unit tests and developing a universal verifier applicable to any language. All that is required for a new language is a small configuration file, significantly democratizing code generation and making advanced tools accessible for a wider range of scientific and engineering domains. How does Agnostics achieve universal code generation? The process begins by rewriting existing unit tests into a universal input-output format, standardizing the way tests are presented across languages. Next, a verifier is constructed to check code functionality regardless of programming language. The Qwen3 model, with 4 billion parameters, is then fine-tuned on 5 rare languages: Lua, Julia, R, OCaml, and Fortran. This approach not only outperforms much larger models, but also scales effortlessly to new languages. The core technical methodology is reinforcement learning, where the model iteratively improves through trial and error. The impact of Agnostics extends beyond technical achievement. The motivation arose from the observation that laboratories using obscure or legacy programming languages were being left behind by the AI revolution. By enabling universal code generation, Agnostics opens new opportunities for scientific research, engineering, and the maintenance of legacy systems. Collaboration becomes easier as AI can now operate fluently across diverse languages. This work was driven by real-world needs, not just technical curiosity, and it sets a new standard for inclusivity and accessibility in AI research. Looking forward, the future of machine learning resembles a well-tended garden, one where models are both trustworthy and nimble. The vision is for AI systems to provide clear explanations for their decisions, much like nutrition labels on food products. Growth in this field is being guided by both technical rigor and human values. Models are being designed to handle unforeseen scenarios and remain accessible on any device, from servers to smartphones. Privacy and federated learning are increasingly being incorporated as foundational features. This evolution is akin to cultivating a garden, balancing innovative growth with wise stewardship. In conclusion, today's research is fundamentally reshaping the landscape of machine learning, from efficiency improvements to enhanced interpretability. The work of Boruch-Grishecki et al. And others demonstrates the importance of inclusivity and methodological rigor. Progress in this field is increasingly defined by smart, thoughtful choices, not just by computational power. Listeners are encouraged to engage, test new tools, share ideas, or contribute original research. The frontier of AI is open to all, inviting participation from developers, policymakers, and curious minds alike. This episode was created through a synthesis of advanced AI and human expertise. GPT 4.1 from OpenAI was employed for summarizing and structuring content, while text-to-speech was handled by OpenAI, and visuals were generated using Google tools. A human expert thoroughly reviewed all synthesized content for accuracy and clarity. References are provided for every cited paper and author. Please note that some oversights may remain. And audience feedback is welcomed to further enhance reliability. In this podcast, we bring you the latest breakthroughs in computer science and AI straight from arXiv preprint server. From neural networks to quantum computing, we simplify complex research so you can stay ahead. Whether you're a developer, researcher, or tech enthusiast, AI Frontiers keeps you informed daily. Thanks for listening. If you enjoyed this episode, subscribe for daily updates. See you tomorrow with more cutting-edge AI insights. Disclaimer: this video uses arXiv preprint server content under its API terms of use. AI Frontiers is not affiliated with or endorsed by arXiv preprint server.